In the Virtuoso system design platform flow, discrete components such as capacitors, resistors, and inductors require the use of a part underscore table view. If we open a part table view for a discrete component, we see that it is a table of property and value pairs. The properties listed in the part table view are user customizable. And when you add a discrete component to your schematic, you select an entry from the table, and the value for each of the properties will be annotated to your schematic. Using the part table view is simple. When we go to add an instance for one of our discrete components, such as a capacitor, if we select the Select Parts button in the Add Instance form, the physical part filter is displayed. The properties are displayed in the header of the PPT rows section of the form, and all the entries in the table are listed. When we select an entry, we can select the value, pack type, and part number for the particular component that we've selected. When we pick the OK button, the value for the properties are populated in the Add Instance form, and when we add that part to our schematic, those properties will be annotated to the part. Many of these properties will get passed along to the physical layout, such as vendor part number or internal part number, so they can be populated into the bill of material. Other properties that must be annotated to the physical design include the JEDEC_type property, which will tell SIP layout which footprint to use when the component is placed in the physical design. There are also properties that help accommodate the simulation flow in VSDP. The resistors, capacitors, and inductors that you use in your VSDP flow can be created from templates provided from Cadence, and you can import your physical parts tables from comma-separated valued files that you can keep in a spreadsheet or may be downloaded from a vendor website. Here we see an example of a spreadsheet that stores the physical parts table for a capacitor. It is important to note that the properties are listed in the first two rows of the spreadsheet. We'll also note that the required columns for the spreadsheet are the part underscore number column, the JEDEC_type column, and the part column. We'll discuss these in more detail when we import our comma-separated file. For a capacitor, you may need properties such as tolerance and voltage, which will allow you to select other parameters on your capacitors, all the way down to perhaps a manufacturer's part number, so that a specific capacitor can be purchased and be placed based on a bill of material. We can keep our part table in a spreadsheet file, but in order to import it as a physical parts table, we'll be using the conversion toolbox. So we'll save our spreadsheet as a comma-separated file in an ASCII text format. The SIP-lib template library is in your IC 617 software hierarchy under Tools, DF2, ETSI, CDS-lib, VSDP, SIP-lib template. And in this library, you'll find three templates for your three discrete components: a capacitor, an inductor, and a resistor. What we'll be doing in this case is creating a capacitor that we can use in the VSDP flow, and we'll create it from this capacitor template in the SIP-lib template library, and we'll be putting our new cell in the SIP discretes library that we've just created and currently has no cells in it. We use the conversion toolbox to create our discrete capacitor that we'll be using in the VSDP flow. So from the CIW window, we'll select Tools, Conversion Toolbox to open our conversion toolbox. From the conversion toolbox, we can select the Import CSV for Packaging and Simulations View button. We can now use the Browse button to navigate to the CSV file that we had exported out of our spreadsheet. After selecting the CSV file, we'll select the Next button to go to the next step of the wizard. The next step of the wizard lists the different rows that were found in our CSV file. The first row must be the header row that lists the different properties that will be found in our CSV file. And the second row is generally the list of the property names that will be added to the CDF for the part that we are creating. So we'll select the CDF prompt row available checkbox. Depending on where our CSV file came from, this would allow us to have our header information in the first row, and then the second row be the name that we would like to use in the CDF in case the two did not match. We'll select the Next button in the wizard, and here we must define each of our columns or our properties as either key or injected properties. Key properties will get added to our schematic and can be used by simulation and other tools, while the injected properties will be packaged along with our physical netlist and will be available to export to SIP layout for the physical layout. Our getic_type property is a very important property which defines which footprint will be used by SIP layout when the component is placed in the design, so this must be an injected property. Any other properties that we wish to have on our bill of material, such as perhaps vendor part number, would also have to be listed as an injected property. If we scroll down, we find our part property, which is a required property for our CSV file. It is not, however, used in the VSDP flow other than for creating our part table view. So we'll leave this property set as ignored. Then we'll select the Next button in the wizard to move to the next panel of the wizard. Here we'll set our template library to our SimpLib template, and since we're working on a capacitor for our VSDP flow, we'll set our cell field to cap. In the target settings field is the library that our new VSDP capacitor will be added to. So we'll select our empty SIP discretes library and give our cell a new name, perhaps cap_SIP, since it's a capacitor that we'll be using on our system level schematic that will flow to SIP layout. Our templates have an S parameter view and a SPICE view template that will also be copied to our target directory. Down in the part map table section of the form, we see a single entry for cap_SIP. This was populated from the part header that is mandatory in our CSV file. When we select the row for that CSV file, we can select the Apply button, and our template library, our template cell, target library, and target cell is populated from the top portion of the form. Note that the part_no column is also a mandatory column. The value in this field will be used for simulation. If we bind this part to a Spectre model, then the value of the model will come from our value field. But if we bind to a S parameter file, then the name of the S parameter file will come from our part number field with a .s2p appended to the file name. We'll see this in just a minute when we add our new capacitor to our schematic. When we select the Finish button in the Import CSV form, and go back to the library manager, we can see that the cap_SIP cell has been placed in our SIP discretes library, and our views have been created, including our part table view. Now, if we were to add this new cell to our schematic, we can right mouse button in our Virtuoso Schematic Editor canvas, select the Add Instance option. And from our new SIP discretes library, we'll add our new cap_SIP cell. And as we're adding the part, we can select the Select Parts button in the Add Instance form to open the part table view that's been created for our discrete capacitor. We'll select the third entry in the table, which has a value of 390 picofarads and a part number of the GRM0222C1H101J010. When we select that entry and select the OK button, the value for all of the headers or properties in our part table are populated in the add instance form and included with the capacitor when we add that capacitor to our schematic. We'll wire our capacitor in parallel with the other capacitor just so we can generate a netlist for simulation. Before we generate our simulation netlist, we'll revisit the capacitor that we have just added by selecting the capacitor and editing its properties. It is important to emphasize the JEDEC_type property when we package our schematic and export it to SIP layout. SIP layout will look for a footprint named 804.psm through the SIP layout package symbol path to place this instantiation of our capacitor. Also notice that the part_number property value came from our physical parts table, as well as our value, which got populated in the capacitance field as well. Let's close our system level schematic and save it. And we'll open the simulation configuration for our test bench schematic, which in turn calls our system level schematic through hierarchy. On our test bench schematic, we see the test bench symbol, which represents the system level schematic we were just looking at. We'd like to generate a simulation netlist for. In our hierarchy manager, if we open our system level schematic folder, we can see the different components that have been placed on our system level schematic. And we see our new C2, which we just added from our SIP discrete library, and a cell named cap_SIP. We'll first bind that instance to a Spectre model. And we'll update our schematic. And then from our test bench schematic, we'll launch the ADE assembler. We have an existing view in the ADE assembler, and when we open it, we can pick the simulation button to generate our simulation netlist. When the simulation completes, we can go back up and find the netlist that was created for simulation. And if we open that netlist, we can scroll down, see the different parts in our design, and as we scroll down, we find our system level schematic that we were looking at. This is the schematic that we added our new capacitor to. We see the different individual discrete components that were on our schematic, and as we scroll down, we find C2, the capacitor that we added out of our SIP discrete library. And since we bound this component to the Spectre model, the capacitor value, 390 picofarads, was taken from the capacitor property, which in turn was taken from the value that we had selected from the physical parts table. Similarly, we'll go back and bind this same capacitor to an S parameter model. We'll exit the ADE assembler, and back in our hierarchy editor, we'll find our C2 capacitor again, and instead of binding to the Spectre model, we'll select the S parameter model. We'll update our schematic again, and once again we'll launch the ADE assembler to go look at the simulation netlist that gets created. When we run our simulation, and the simulation completes, we can again scroll back up And when we look at our simulation netlist, we'll be able to find our system level schematic again. And on our system level schematic, if we again scroll down and find our C2 component, this time we can see that it points to a file named grm0222C1H101J010.S2P. The base name of this file name came from the part underscore number property that was in our physical parts table. So, as we can see, the part underscore table view of your discrete components, such as inductors, capacitors, and resistors, can be generated from CSV files, and the properties that are imported onto your schematic can be passed along to SIP layout for the bill of material and also for the physical footprint that is used by the component. Similarly, properties for simulation are also instantiated from selections made by the physical parts table.